All right, we're taking a look at page 11. We are going to be looking at equations that have variables as exponents here. Okay, that's what we're going to be seeing right here. Notice there's going to be some process to actually solve them. All right? I'm going to go ahead and skip these first four. We could do them. Actually, I'll skip the first two. C and D is kind of where I want to start. Let's look here at page 11, letter C. The goal is, yep, page 12, thank you, sorry. Page 12, letter C. I want to take both of these bases right here, and I want to rewrite them. Right here for this one, I want to rewrite both of these numbers with the same base. Here's what I mean. This is 2. Could I rewrite the 4 also as a 2? 2 to what power? To the second, right? If I do that, notice how the exponents don't change. I still have the 3x here and the x plus 1. But here's one thing that does happen. Students, whenever I have the same base on both sides of the equal sign, they just simplify out. It's like if I had an equation and I added 2 to this side and I added 2 to that side. Aren't those the same thing? Right? Due to one side, due to the other. That's what this is as well. I have a base of the same number that's exactly the same. These two numbers right here, they just simplify out. So what I have left is just 3x equals 2x plus 1. See how that's just the exponents there? These are both just the exponents.
I don't have my notes packet.
Okay.
I lost it. Is there any extras anywhere?
Great question.
Check right there on the by the hand sanitizer. I got to put it in there somewhere.
Those are just the exponents, right? Could we not just solve it from there? 3x equals 2x plus 2. X equals 2. Could I check my answer here? What I mean by that is, if I put a 2 in the exponent, it says 2 raised to the 3 times 2. Isn't that just 64? If I put a 2 on the other side, 4 raised to the 2 plus 1, did I get the same thing on both sides of the equal sign? I did, right? See if you can try that here on D. What I mean by that is we already have a 3. My question is, what would this have to be? We know it has to be a 3 as a base. What would you get for the exponent though? In order for it to be the exact same as 27, Dylan, what is that? 3 to what power? Wouldn't this be the same as 27 right here? 3 to the third? I could fill in the exponents as they were, x plus 2 and 2x. Andrew, now that I have the same bases, what would be the next step? Let's do it. So what's on the left, what's on the right, if they're canceled out? Yeet. What's on the other side, sorry? 2x, 2. Move the x over. X is 2. Oh, yeah. I made a mistake here. Thank you for catching that here. These right here, as you guys correctly said, 6x, right? So wouldn't that make it 5x if I move the x's over then? Right? So my actual answer would be 2/5 or 0.4. Three raised to the 0.4 plus 2. 27 raised to the 2 times 0.4. We come up with exactly the same thing here. All right. What I want to do here is, to start with, we're going to see some equations that have the variable in the exponent. These are called exponential equations. Whenever you see the variables in the exponent, that's considered an exponential equation. There are 3 steps that we're going to use to solve that. Number 1, we are going to need to isolate the base and the exponent. That's the first thing we're going to do. Isolate the base and the exponent. Step 2. We are going to rewrite this in log form. So that is 8D right there. Just switching the forms. And the last part, we are going to use, and we will call this the change of base formula. Change of base. And solve. Let's kind of go through that right here. Number 1, or letter A. I'm going to underline the base of the exponent and the exponent. Actually, I guess I'll just put it in a box here. This is what I'm trying to isolate. Step 1, the base and everything in the exponent. Is there anything on the left side of the equal sign that's not in the box? No. So that just means step 1 is already done for us, right? Don't have to do it. Very nice. More of those, please. Step 2. Right? Step 1 is already done. Step 2. We're going to rewrite this in log form. Remember, it's the log. Come on, penny pen. Of a base.
Why is there a second hole in log?
Well, I think my green pen's not working here. I meant to make that a G, and every time I write over here it works, and then when I come on this side it doesn't work.
It's starting to become visible. There we go, we have it. We have it now.
The log base what number of another number equals what? Right? So we just got to switch the order for it. Allie, I have 3 different things. I have the 15, that's 1. I have the 3x, that's 2. And I have the 285, that's the 3rd thing. Pick one of those, please. And tell me which box it goes in. Little bitty box right here, 15. Right? This is what we were looking at for the log. Cole, you with us? Right, this is 8D, that half sheet of paper. What goes next? Is it 3x or 285? Just the 285, right? Followed by 3x. That's the second step right there. Here's the third step, change of base. This is something that we know now how to use our calculators for the logs. We couldn't do that up until recently, hence the test. But on the last lesson, we talked about the change of base formula. The change of base formula says if you have a log base a number of another number, you can rewrite this in a fraction, always doing the same thing. Sydney, do you remember? Which one goes on top? Is it the bigger number or the one that's bigger in font size? Bigger in font size. Now in this case it is the same number, right? But yes, it's the one that's bigger in font size. So 285 divided by log of 15. Students, when I use this formula, recall it doesn't matter. I could use the natural log, the ln, or the log log. Both of them will give you the same answer. Pull out your calculator, please. Pull out your calculator. Can you put this into the calculator? Essentially what this is saying is 15 to what power is 285? I always like to use the natural log, but the log log works just fine. 285. Make sure that you close the parentheses. Divided by the natural log of 15. Again, no matter what log you use, make sure it's the same one for both. Anybody use the log log? Did you get the same answer as me? Mm-hmm. Yep. Close the parentheses again. Here's what that means. That means that this thing is equal to 3x. See what you put? See how you put it in? Don't clear it. It's hard for me to see it when you clear it.
285.
Hit the up arrow. Hit the up arrow. I don't know. Hit the up arrow. See on your calculator you have an up arrow? What did you just do it and then that shows you what you entered in.
285 divided by.
But it's not just log on the bottom, you have to do log on the top and the bottom. Students, is x by itself right here? June, how do I get x by itself? Well, how do I move that 3 over? Divide by 3, right? So I have a random number in my calculator. I could just divide by 3. And there it is. Now, students, if I did what June had suggested and divided by 3 over here, where would this 3 go? Would it go on the top or the bottom with this log? Which part would it go on? It would go on the bottom, right? So what you could do is you could take this in your calculator and notice if I just use the division sign, I have to group it together with a parenthesis. See how I have the exact same answer? Maybe you are lucky enough to have a calculator that gives you a clear separation of what's on the top and the bottom. Again, I could use the log log. 3 log log 15. See how it's again just the same answer? Right? So either way, you could put this one time in your calculator, or like we did, we kept a running total, and in this case, we just divided by 3. I'm going to keep it to 4 decimals here. Your answers to these problems might appear to be random decimals for some of the problems. And we can go from there. All right, take a look at letter B. Very similar, obviously different numbers. See if you can kind of go through that process the exact same way. Students, did you have step 1 already being finished? Right here. Log of 130 divided by log of 5 equals 2x. Again, you could put that into the calculator. The natural log of 130 divided by the natural log of 5. Divide it by 2 because, again, it's 2 times x. And that's what I come up with right here, right? 1.512. Now, be mindful. If I needed to do this, I might have it written this way. The reason I might write it this way is because this is what we call the exact answer. Whereas if I just put it into the calculator, I get a decimal approximation of x equals 1.512. That is the approximation where I'm rounding my answer. So be mindful, especially as we get to a Math Excel problem. They may ask you to write something as an exact answer, then write it as the approximation as well. Notice if I just did it this way, I didn't even need a calculator. Right? The whole thing for the calculator is just by plugging that in to get a random decimal. Okay, let me show you. Why don't you walk up here and show me how you did it then? All right, students. Letter C, pretty straightforward. To be honest with you, I meant to change this problem just because of it's actually not even getting harder, isn't it? Just log base 4 of 19 equals x. 4 to what power equals 19? That's essentially what it's asking. Look at the green papers on the cabinet. What exponent is approximately going to give us 19? Between what two exponents? Well, 4 squared is 16, 4 to the third is 64. It's going to be between 2 and 3. Is it closer to 2 or closer to 3? Closer to 2, right? Let's try it out. Let's check it out. The log of 19 divided by the common log of 4. Closer to 2, for show. All right. Here's one that we need to see. Remember we had 3 steps, right? Isolate, rewrite, calculator, and solve. Isolate, rewrite, calculate, and solve. Right here, I need to get just this 3 and the x by itself. Move over first. What do I have to move over first? Is it the negative sign or the 5? The 5, right? So, if I move it over, it is minus 5 on both sides. So I have a negative 45. I have an equal sign. I have a negative, and then my base is 3 raised to the x. Students, what say you? Is this base an exponent? Is it really isolated yet?
No.
There's a negative sign there, right?
Yeah.
How do we get rid of the negative sign?
Divide by negative 1.
Yeah, just multiply by negative 1 or divide by negative 1, right? Let's go ahead and do that. 3 raised to the x equals 45. Cole, KJ, you with us? Students, right here. It looks like I've isolated it. How do I do this? Log base number of what number equals my answer? What goes where? Right? I just isolated it, right, to there. I'm now going to rewrite it. Marin, pick one of the numbers, 3x or 45, and tell me which box you...
You would go in the first box.
Yeah. X. Students, I just completed it. I just rewrote it. On top of the log, because it's bigger in font size, right? The one that takes up more space on the paper. 3 to what power is 45? Any guess between what two numbers would my answer be? 5 divided by the common log of 3. I got it. Looks like it's between 3 and 4. X equals 3.464. Actually, we'll call it 65, and then a 0. If I'm rounding to 4 decimal places, why do I need that 0 there? Well, I need that there.
It's rounded.
It's rounded, right? If I just put 465 and I was asked to round it to 4 decimal places, that makes it assume that it's only 3 in the answer, right? If it's 4, I need to put zeros there to round it. All right, let's take a look at a story problem. Some of the story problems from 7B can now turn into this idea right here. Let me add a couple words here. Wood is a sustainable, renewable, natural resource growing continuously. Growing continuously when you manage forests properly. The lumber company that you have has 1,200,000 trees. You plan to harvest 7%. Harvest means what? Add 7% or take away? Take away, right? You harvest something, you're pulling it away from the ground. You harvest 7% of the trees each year. How many years will it take the harvest to be half of the... Is this word right here, the word half? You might see the word double. That's fine. But they all have the same ideas, because no matter what number I start with, oops, sorry about that, I know my final answer is only half of it. So I could start at 10. Wouldn't half of it just be 5? I guess we should ask ourselves this question. What formula am I using for this? What 8B formula am I using? It's definitely going down. The PERT formula though, right? It says continuous. Continuous is like the Joker. It trumps everything. Right? You see the word continuous, you know that's the formula you have to use. Yeah. But I mean, technically there's no jokers in there.
Yeah.
But I'm just saying, like, if you're playing war, going back to like the good old days.
Oh, I never used the jokers anymore. Yo, we outlawed those.
Wow. You must not be playing with any kids. My kids mandate that there's... They always try to steal them. Like, go in there, like, stack the deck for them.
I was thinking.
No worries, man. It's like a trump for it, right? Anytime I see the word continuous, I need to be using that formula. I'm using the PERT formula. So notice it's E. It says it's losing 7%, so negative 0.07. And the question is, how long does it take? We saw a question like that. Remember, we were just plugging numbers in on the learning check? Oh, did it go below $500 after the first year, the second year, and so on, right? Now we can actually use logarithms to solve this. Students, is this right here, is it isolated on the right side of the equal sign? No. What do I have to do with this 1,200,000? Don't I have to move it over? Right? So if I move it over, which means by division, all of this simplifies to be 0.5. Think about it. This right here is the exact same way. I would divide by 10, and would I not still get 0.5? So what's left over? E raised to the negative 0.07t, negative 0.07t. Well, think about this. We just did step 1. We just isolated the base and the exponent. What kind of log am I going to use right here?
Natural.
Am I not going to use the natural log? It has a base e. So students, isn't it just the natural log of 0.5 equals that right there? Notice I just switched the order. See how the exponent is the answer? The base e goes with the log, and then the answer in exponential was the argument. I don't need any special formulas to plug the natural log into the calculator. That's why I like it so much. We can just use the natural log of 0.5. Students, is t by itself yet?
No.
When I just divide it by negative 0.07?
No.
See how this can give us more of an accurate answer than just plugging in numbers? 9.9 years. That's how long it would take. Right? I could take right here and take my number. And I could put a 9 in. See how it's not quite to 600,000 yet? I could put a 10 in. See how it's already below 600,000? So I know it's between those values right there. Looks like a, there we go. Alright, let's switch it over. Let's do some logs. Logs are the same thing, but notice, see how I've never seen this yet today? See how there's a word log in the original problem? That means it's a logarithmic equation, and I'm going to use these 3 steps to solve it. The first step is to either condense or isolate the log. Right? So remember when we saw plus signs, we knew they were multiply? Maybe we see a number added or subtracted outside of the log. I know I have to move that over. I'm going to then rewrite in exponential form. So I'm going the other direction. Condense or isolate the log. Rewrite in exponential form. And then use the calculator and solve. Alright, let's see what we have here. Students, log log. And what comes immediately after it, in this case in the parentheses. Is there anything on the left side of the equal sign that's outside of what I've underlined? No, there's not, right? So step 1 is already done. Step 2, let's rewrite this in exponential form. Bless you. What's the base of the log, JJ? Yeah. Because I need it for right here, right? Not negative 3. What number is between the G and that parenthesis there? 10. This number right here, students, is a 10. I've got to make sure that I use it right there. Now I know my exponent. My exponent is a 2.
It's 100. 10 squared is 100.
Followed by the last part, 4x minus 3. We just did step 2. Now I can use the calculator to solve. Do you really need the calculator for 10 squared? Probably not. But if you could use it, obviously, right? You could do it a couple ways. 10 squared might be the easiest way, but remember on that LOG button, there's a 10 to the x. I could just use that. Right there. Right? Either 10 would be fine. 10 squared is a hundo. Equals 4x minus 3. I could add 3 to both sides. And I could divide by 4. Right there it is.
Is the decimal fine, or would you
Yeah, decimal's fine. I just have to use my calculator then, and I'm not ready to do that. Hey, Mitchell, what's up?
So is the base always going to be 10 unless there's a number there?
Always. And now if it's a natural log, it wouldn't be 10. It would be E, right? But yes, good question. B right here. Looks like step 1 is already done. Let's do step 2. No, I have 3 numbers, right? I have the one between the G and the parenthesis.
It's 10, yeah, 10.
I have a 3 minus 2x and a negative 1. Noah, tell me which one would go in what box, or just pick one of them at least.
10 in the first spot.
You got it. KJ, where does the negative 1 go? As the exponent or the answer?
Exponent.
That means that 3 minus 2x is the answer. Maybe this is one you do need. Students, do you need to put 10 to the negative first in the calculator? Maybe. Just 0.1. Or 1/10, 1 over 10, equals 3 minus 2x. Subtract 3. Divide by negative 2. Well, 29 divided by 2 would be 14.5. So isn't 2.9 1.45 right there? 1.45. Again, calculators could be helpful. This one on letter C is the first time we see that we actually can condense or isolate. What do we see here, students? Anything outside of the log and its argument there? How do I move the 3 over? I don't want to. Tough. Do it anyway. Ten to the negative first equals 6x. Like I said, you could just put it into your calculator. Another way of doing it is just by making it a fraction. We know negative exponents really just take it to the bottom of the fraction. Students, how do I move the 6 over? Divide it. If I divide it, would it go on top of the fraction on the left or the bottom? Wouldn't it also go on the bottom? So just 1 over 60 equals x right there. see here, last page.
I need to see that one more time.
Okay. I'll show it to you at the end here. Stay with us though, Stephen, not on your phone, please.
Well, I'm not down for me.
Awesome. Thanks, Maddie, for the assist. Here we go. Example 5. Students, we see 2 logs here with the plus sign. What do I have to do with these 2 right here when there's a plus sign between them? I have to multiply them, right? Properties of exponents. Product property says you must multiply them. Didn't I just multiply it together? Right? By distributing equals 1.
But they didn't have the same basis.
Correct. Carter is correct. They must have the same base, which they do, in order to condense it. We will not see ones this year that don't have the same base. Well, I just condensed it. I just wrote it down as 1 log here. Isn't this really 10 to the first equals x squared minus 3x? Isn't that just really 10 equals x squared minus 3x? Sam, how do I do this? I have a problem that says x squared. How am I going to solve this here? I could, but I can't square root just this right side. Thanks, Marion. I'm going to need, well, I could, but I would just get a decimal, right? Anytime I see x squared, move everything to the x squared side. Let's factor this one. What's my answer for the green one right here? Isn't it 5? What's my answer for the purple one? -2. Students, I probably should check these, right? Let's go ahead and put it into the calculator and let's see if we can come up with a pattern here for what works and what doesn't work. If I put 5 back into the original, it's the common log of 5 minus 3 plus the common log of 5. See how I get the answer right there? Let's do the same thing for -2. See how I got an error there? Anytime that I have a negative argument, I cannot do that as a log. Okay, that is considered not possible. So it doesn't look like -2 works. It's just the +5. We could do this one here, right? What does subtraction mean when I condense? Division, right? So, the log of 6 over 3x equals -2. (10 to the -2) equals 6 over 3x. 100, 1 over 100 equals 6 over 3x. Don't I just cross multiply here? 1 times 3x. $600 on the other side.
3x would be 200.
200. We could solve it with the e's.
Let's make it quick. We have
Get the base and the exponent isolated. 4e to the 2x equals 14. Divide both sides by 4. 7 over 2. Natural log of 7 over 2 equals 2x. See how I just rewrote it in a different form? Students, which side would I put into the calculator? The left side or the right side?
Right side.
I can't put the right side in because there's an X, right?
Left side.
If I put the left side in,
Alright.
the natural log of 7 divided by 2. What do I do with my answer to get X by itself?
Divided by 2.
Let's do it. 0.6264, that's what X is. You could see that we could do that in several different ways. Students, the last Math XL is today. 8G, the last Math XL.
I'll show you the work on 8F and 8G on Tuesday.